Okay, number 17, we have a specific heat question. And I know that these questions can be overwhelming because it's so much information. So we're going to go really slow for this question, and I'm going to teach you some tips and tricks, which you can kind of already see how I've laid it out, what those tips and tricks are. So the first thing that I like to do in any type of word problem is underline or highlight the things that I'm going to need, or variables that I can pull out and plug in somewhere. So I've written our specific heat equation right here. And remember that when we have this delta T, this change in temperature, that hidden in that is another equation. So hidden in that is this equation right here, which is temperature final minus temperature initial. And then I have our equation rewritten, and we'll talk about that in a minute. So we have a 22.8 gram piece of metal, and it tells us its initial temperature is 92.6 degrees Celsius. So I would put something like initial T of metal, or you could put TI of metal. Whatever you want to put to tell yourself that's the initial temperature, like that's the temperature of the metal. And it's dropped in some grams of water, and the water is at this temperature. So here's another initial temperature, and you can do it in a different color, you can highlight it, you can do whatever you need to do on the test to help you look at this. So I'm going to put temperature initial of water. Okay, so we have some grams of water and we have some grams of a metal. So we can come down. I always write my variables. And at first I wasn't sure if I was going to need variables for two things or just a metal or what I would need it for. But if we read the rest of the problem, that'll tell us a lot. So all of the heat lost by the metal is used to heat the water, and the final temperature of the water, so we have a final temperature of water and the metal, so that's going to be the same. So we have a T final, and it's the same for the metal and the water. And then we have to calculate the specific heat of the metal. So specific heat of the metal is what we're looking for. And he gives us here the specific heat of water. I'm not sure if he'll give that to you on the test or not. It's always a good idea to memorize any values concerning water, like the density of water or the specific heat of water, because that's always the same. So the specific heat of water is always 4.184 joules per gram degrees Celsius. All right, so now we're going to pull out our information from the problem, and we're going to match it to our variables. So I have in pink, we're going to do water. So I think it's like a purple. My specific heat of water is given to us, right? We know our specific heat of water because we've memorized it, but he's also given it to us. And that's 4.184 joules per gram degrees Celsius. Sweet. I don't know anything about joules. So this Q right here is in joules, and we have nothing in the problem telling us how much energy was made or lost, so we don't know that right now. All right, we know the mass of water. So if we come back up to the problem, it says that our piece of metal is dropped in 46 grams of water. So we have a mass of water. And remember that we wrote down our T initial and we found our T final for water. So that, because I wrote it up here at the top, it makes it easy to come back up to the problem and just pull it out. So our initial temperature for the water, our TI, is 24.7 degrees Celsius. And our final, which is also the same for the metal, is 28.2 degrees Celsius. Okay, so we don't know something about water. We don't know how much energy or heat. We don't know Q yet, but that's okay. We're going to get there. All right, so let's talk about Q metal. We don't know the Q of metal. We don't know how much heat it put out, and so we're just going to put a question mark there. We know the mass of the metal, and the mass of the metal was 22.8 grams. Remember, we saw it up here, right here. We also had our initial temperature, which was 92.6, and our final temperature, which is the same as water, as 28.2. Okay, and remember the question is asking us what the specific heat of that metal is. So we don't know the Q of the metal, and we don't know the specific heat of the metal. But we know the initial temperature, and we know the final temperature. So we have an initial of 92.6 degrees Celsius, and a final of 28.2 degrees Celsius. So my favorite thing to do for these problems is to draw a picture, because I can get easily scrambled by all the numbers and the data. So I have this beaker of water, and I have 46 grams of water, and its temperature was at 24.7 degrees Celsius. And into this water, I'm going to put this hot piece of metal. So I have, 22.8 grams of metal, and it was really hot, right? It was 92.6 degrees Celsius. And I'm going to put that in my water. And if you think about what's going to happen, well, the water is colder and the metal is hotter, so the water is going to heat up and the metal is going to cool down. And they're going to come to the same temperature. So the amount of heat that the metal puts out is going to be absorbed by the by the water. So the metal is giving heat to the water, and the water is taking it. And it ends at a temperature of 28.2 degrees Celsius for both the metal and the water. So if we can find the Q of water, if we can find out how much heat or energy the water absorbed, then we know how much heat or energy the metal gave to the water, because they are equal to each other. We could even write it like this. We could write Q metal, and remember it's giving, so it's going down, it's negative, is equal to Q water. And water is positive because it's taking the energy or the heat from the metal. So let's find the Q of water, because if we can find the Q of water, we'll know the Q of metal. And we know that if we have all of our variables except for one variable, so if we find this, then we can find our specific heat because we have everything else. So let's find our Q of water. Let's find out how much energy or heat the water absorbed. And luckily, all we have to do for that is just plug and chug into our equation. Now, you can find the change in temperature first if you want, or you can put it into the equation. Either way, I'm going to go ahead and write it out. So my Q of water, which I know will be positive because it's taking the heat, is going to be the mass times the specific heat times our change in temperature, which is going to be final minus initial. Okay, so I've already done this math on my calculator, and my internet isn't working for my iPad, so I can't show you how to do it. But the answer that I got for Q water, which is how much energy or heat it absorbed, was 672.98 joules. So remember, this number right here is how much was gained by the water, and it was given by the metal. So the metal's Q, we now know. We know the metal's Q because negative Q of metal equals positive Q of water. So we just say negative 672.98 joules. And now we can find the specific heat of our metal because we have all the other variables that we need. So we can find this. We have all the other variables. The problem is the equation that we have is set up like this. We're looking for this, not this. So we need to rearrange our equation. I've already done it here, but we can do it together so that you have some practice with it. So let's do Q equals mass times specific heat times change in temperature. And remember that right now we want to solve for specific heat. So how can I get specific heat on the other side of the equal sign and the mass and the change of temperature with the Q? Well, since everything on this side is multiplied, if I divide it out, if I divide mass and if I divide change in temperature, and anything I do on this side, I have to do on this side. Well, now I've isolated specific heat. So my specific heat equation that we're just going to plug and chug is going to be specific heat equals Q divided by mass times change in temperature. So let's do it. We don't know our specific heat. We do know Q. It's negative 672.98 joules. Ooh, my Wi-Fi is working. Okay, well, I already have the math done, so we'll just go ahead and plug it in. But you'll need to put this in parentheses in your calculator. So you would type negative 6.72.98 in parentheses, and then you would do the division sign like this. All right, so we're dividing by mass, which was 22.8 grams, and then multiplying that by our change in temperature, which was 28.2, because we go final minus initial, minus 92.6. And we get an answer that's negative 0.458. Now, specific heat is always a positive number. We'll never get a negative number for specific heat. This negative is just telling us something. It's giving us context for the problem. It's telling us that metal lost some energy or heat. But we know that a specific heat is positive, so we're going to rewrite it as positive 0.458. We're going to go back up to our answers. And we see that there are 4 answers, right? And sneakily, we have one that is a negative 0.459, which is what we got. We got a negative 0.459, 4.58, so our rounding is a little different. But we know that a specific heat, which is what we looked for, cannot be negative. So we know that the answer then is going to be positive 0.459.